Okay, so I suppose my voice should be audible now. Let me just start over from the very beginning. All right. Hello, hello. Okay. Okay. So I suppose my voice should be audible now. Let me just start over from the very beginning. All right. So good evening, ladies and gentlemen. Good evening, ladies and gentlemen. My name is Vardhan, and I'm super excited to be here on Edureka Live with you guys. In my previous session on DevOps, I explained how to Dockerize an Angular application using Git, Jenkins, and Docker. Today's session is the next in that same Docker series, and today I will show you how to use Docker Compose to containerize not just one Angular application, but to containerize a mean stack application. Well, in simpler terms, the difference between my previous session and today's session is that in my previous session, I created one Docker container and hosted an Angular application inside it. But this time around, I will be using Docker Compose to create 3 different containers for hosting the mean stack application. Okay, Angular will be hosted in one container, MongoDB will be hosted in another container, Node.js and Express will be hosted in the third container. And these 3 containers would be up and running together to form my web service. Okay guys, that's what I'm going to do today. And if you guys get any doubt during the session, you can raise them by putting them in the comment box, and either my team or I will myself answer them for you. So sit back, relax, and enjoy Edureka Live for the next 30 minutes to learn how Docker Compose can be used to containerize multi-container applications. Okay, but before I get started, I want to first of all ask you people a couple of questions. Firstly, are you all aware of what Docker is? And do you all know what a mean stack application is? Okay, I have a mixed response over here. Some of you people know what they are, and some of you do not. Well, don't worry guys, as you can see from the agenda, I will first introduce you to what is Docker, after which I will talk about what is Docker Compose. Then I will tell you how to build your own Docker containers and how to get them to interact with one another. Alright, and since I'm containerizing a mean stack application, I will briefly tell you what a mean stack application is, and finally I will give you a demonstration of containerizing them. Alright guys, so enough talk, let's get started. And this is the first topic of my session, and that is what is Docker. And as you can see the definition that's there on the screen, right? Docker is a containerization platform which packages your application and all its dependencies together in the form of containers so as to ensure that your application works seamlessly in any environment, be it development environment or testing environment or production environment. And as you can see from the image on your screen, we have 2 different containers over here, right? Each of these containers are running their own set of applications. It contains its own dependencies and packages and libraries, and these are all tightly coupled together to form that container. And these containers are basically powered by my Docker engine, which is below that. right? And the Docker engine is in turn hosted on your host machine. The host machine can be either Windows, Mac, or even Linux, for that matter of fact. Okay. Now you can ask, what's the big benefit of using Docker over other virtual machines? Well, first of all, the reason we use virtual machines is because servers are really costly, right? So we cannot have just to host one service, we cannot we cannot buy a new server. So we use virtual machines, and we run these virtual machines inside these servers. But the problem with virtual machines again is that they are in turn very heavy on the server. Okay, there's a limit on the number of virtual machines that you can run. Well, in case you are using virtual machines for running and deploying those applications, then you will have to, of course, start those virtual machines, right? Here, each virtual machine will be running one application, and the problem that is going to arise is when you do that, you will have problems of memory resources. So, too much RAM will be allocated for each virtual machine, and that is going to be the overhead. Okay, so pre-allocated RAM will be there, and a part of your memory resources would be taken away, and this would make the web server slow. And sometimes, if it's a little too slow, it would cause behavioral problems. Correct? So it can be any server or even your system. If you have your system and if you start multiple virtual machines in your system, you have those problems, right? That's the big problem with virtual machines. And this is where Docker comes in, and it eliminates that problem, because to Docker you don't need to allocate any memory in advance. The memory that it needs, it would take it only when the Docker container is active, and even that memory is not going to be too much. Okay. And other benefits with the Docker are that since these containers are lightweight, they can be easily spun into action, right? And they're not going to be hard on the they're not going to be heavy on the server. And besides, they can also be shared with other collaborators easily by uploading these to the Docker Hub. Okay, you can just package these applications into these containers and share those containers or images with other people. And by just executing that image, they will have the container running and the service that is there inside that container. So, but in case of virtual machines, we'll have to export the virtual machine and then transfer it. And a virtual machine is going to be really big, right? It's going to have a lot of memory. So that's the benefit with Docker. So now that you know what Docker is, it's time I tell you how to create these Docker containers, because Docker containers are the actual deal, right? These Docker containers are created by running the Docker images, okay? And the Docker images are something that you can either pull from the Docker Hub, or you can create your own custom Docker image by writing Docker files. Okay, so as you can see from this image, this is your Docker container, which is going to provide you the actual service, okay? And these can be spun into action by the Docker image. So you download this Docker image from the Docker Hub, right? Or you can create a new Docker image of your own by writing a Docker file. And inside the Docker file, you will have commands and instructions as to which Docker image to use as the base image, and what actions to be performed inside that image, which port numbers to be exposed. All these details will have to be specified inside the Docker file. And when you do that, you will have a Docker image which is custom made by you, okay? And you can simply run that and get a Docker container out of that. Now, if you want to share it with other people, then you can simply upload this custom Docker image of yours to the Docker Hub. And the Docker Hub, what it's going to do is it's going to help you. It's like a medium where you can meet with other people, right? You can share it with other people. They can download the Docker image, and by simply running that Docker image, they will get a container. So they'll create a duplicate of your environment, whatever you're executing here, that even they can spin that same service. And in the industry, this is how it works. So these Docker images are uploaded to the Docker Hub, and they are downloaded at the production end or at the staging server, and they are just simply spun into action. And once the container is up and running, once it's active, the web service that is there inside the container is also active. Okay, and that's how the industry works. That's the simple way to create Docker containers. Now that you know how to create these Docker containers, now let's see what is Docker Compose. Okay, And the first line that this slide says is Docker Compose is used to run multi-container applications. Well, can you people guess what that is? Multi-container applications. Multi-container application simply means that you have when you have to use services which are spun over multiple containers. So in the previous example, I spoke about. So here I said that you will have one container and you can install one service inside that container, right? You'll be hosting one service inside that container. Now this would work well for a small service. If you want to host a Jenkins server, then that would work. If you want to host a Tomcat server or an Ubuntu, if you want to host a Tomcat service, then that would work, right? You can simply download one Ubuntu image and then you can install the servers there. That's how simple it is. But in the industry today, it's what if you want to host a wide scale or a large scale application, right? An application which has multiple services, and these services are there such that they cannot be hosted on the same machine. Okay, you cannot host these services on the same virtual machine because there'll be too much overhead. So for a similar reason, you might also want to create those services in different containers, right? You can probably have only one container. You can have only one service inside one container. So at that point of time, you can have 3 different containers, and in each container you will have one particular service. Now if it's a Jenkins server, you will have that inside this container number 1, and if it's a Tomcat server, you can have that inside the container number 2, and if you want another web server to be hosted, then you can host that inside a container number 3. And the Docker Compose file is what's going to help you communicate. It's going to help the containers communicate with one another, right? So that's the benefit of using Docker Compose. And how it works is like this. So you have the Docker Compose file in which you would have written commands and commands to create containers based on the Docker files which are present. So similar to creating a container, in the previous slide I told you that to create one container you need a Docker file, right? So the same way you create those containers with the help of a Docker file, and in turn you use a Docker Compose file to call these Docker files. Okay, so when the Docker Compose file is executed, the containers which are spun from the Docker files, they can communicate with each other. So the Docker Compose file creates these 3 Docker files. If it creates these 3 containers with the help of these 3 Docker files, then these 3 containers can interact with one another based on the other operations and the commands which are specified inside the Compose file. Inside the Compose file, you can specify the port numbers which will be open in these containers, and to those ports, requests can be made by the other container and they can communicate with one another. So that's how things happen, right? And an example that I'm going to show you is that of a mean application. You can see that. So mean here stands for M stands for MongoDB, E stands for Express, A stands for Angular, and N stands for Node.js. So we have these 4 services, and together they form the mean stack application, okay, which is a web service. And what I will be doing is I will be hosting these 4 services inside 3 containers. Okay. So to explain about mean in more deeper sense, let me go to the next slide. And for the sake of those people who do not know much about web services, and especially that of mean stack, this slide is dedicated to you people. Okay, so like I said, I told you what mean stands for, right? Now mean is a full stack JavaScript solution that helps you build fast, robust and maintainable production web applications using MongoDB, Express, Angular and Node.js. So in my case, what I told you earlier was that I have 3 different services, right? So the web service would, well, not just my web service, but in general, any web service would have these 3 components. Would have a front end, it should have a back end server, and then it should have a database, right? Your front end client would be here, and I'm going to use AngularJS to be my front end client, and my back end server would be Node.js and Express, and the database would be MongoDB. So when any of my customers, or if anyone interacts, they will interact with the front end, right? So AngularJS is a single page application, right? They will interact with this particular client, and whatever actions are performed and whatever requests are made, that would go to the server. Now the server is the actual intermediary between the database and the client. So whatever requests come from the client, it would perform those actions, and at times if it needs to fetch data from the database, it would do so. It would go to the database, access and get the data and send it back to the client. So that's how the whole web service architecture is like. Okay, and this is what I'm going to do. I'm going to create 3 different containers for these 3 different services and deploy them, right? So if there are no doubts, I can go to my demonstration and show you how to containerize and deploy a main application by using Docker Compose. So let me just open up my virtual machine here. This is my VM. Guys, please let me know if you can see my virtual machine here. Okay, great. So first of all, I want to show you my Docker Compose file, which is used to create the containers. Okay, my Docker Compose file is present over here in this folder. Meanstack app this is the project of mine, and we have a Docker Compose.yaml file, right? So this YAML file contains all the instructions to create the containers. Now, if I open this YAML file, I can show you what instructions are there here. So the first line of code is simply specifying that to use version 3 of Docker Compose. Okay, because certain Docker Compose versions are compatible with only certain versions of your Docker engine. So you have to choose the right version of Docker Compose to interact with your Docker engine. Okay, so that's what I've done here. And then the next thing is you specify the services. Now these services are simply the different containers that you want. Okay, now when I say services : Angular, Express and database, then it means that I'm creating 3 containers. First container's name would be Angular, second container's name would be Express, and my third container's name would be database. Okay, and inside these we've specified rules of how to build those containers. The name of the container is this, and we are building this Angular container by using the Docker file which is present inside this directory. So if you issue a build command, the keyword build stands for building the Docker file which is present. Okay, when you specify the path over here where the Docker file is present, there's a folder called Angular app, as you can see here. So the compose file is over here, YAML file. It would look for this particular folder, Angular app. It would go inside and it would look for the Docker file over here. So the file that is present here, it would use the instructions present in this file to create my Docker container. Alright guys, and similarly to create my second container, which is the Express container, it would look for the Docker file inside this particular directory. Express server is a directory, there's a Docker file over there. It would look for that Docker file and execute the commands over there. And similarly we have database, right? So database is what is going to store my actual data, and this would be my third service. But the difference is I'm not issuing a Docker file to create a Docker container. Okay, I'm simply using a Docker image. Now that is because I don't need to create a custom image. An existing Docker image which is there on the Docker Hub is good enough for my needs. Okay, but in this case there is no Express server image and no Angular image which satisfies my requirements. So I created my own container from an image, and I will show you the rules which are used to create these 2 applications in a minute. But before that, I just want to tell you that to establish connections between this particular container and the host machine, we specify the port number. Okay, so whatever is hosted inside 4200 of my Docker container, that can be accessed on the 4200 port of my host machine. So in my Firefox localhost 4200, I can see the same servers being hosted. And similarly, this container, my Express server container, is hosted on my port number 3000 of my Docker container. right? And that would be again visible on my host machine inside the 3000 port number. And for MongoDB, the port number of my container is 27017, and I'm mapping that to my 27017 of my host machine container. Besides this, there's one extra command, that is the links. Okay, I'm using a link because my data would be stored inside my database, and my server should fetch the data from the database, right? So for establishing the connection over there, there's this command of database. Okay, you're saying links is the command, and when you say database, it would look for this particular container which has this name. So this is the name of the third container, that is database, and yeah, it would look for this and perform the communications with each other. So when I simply execute this Docker compose file, my application would be up and running. My web servers would be up and running on these specified ports. Now before I deploy that and show you what is visible on my port number, I want to simply go to my Docker file and show you how I create each of those containers. Now for those of you who attended my previous session, you would know how to create those applications, but I would anyways give you a brief about them. Okay, so this is the first Docker file, and the steps to build my first container is this. I'm issuing a from command to pull a node image, okay, with the tag number 6. I'm pulling this image, and inside this image I'm making a new directory, that is /user/src/app. Okay, I'm creating a new directory like this inside my container, and I'm changing the working directory to this particular container, to this particular path in my container, and I'm copying the package.json file into this path. Okay, the package.json file is what is going to contain the details about the dependencies and packages which my Angular application needs. Now since this is my Angular container, it should have all the dependencies which it should install and it should need, right? So those are specified over here, and I'm copying this JSON file inside my container. And after that, I'm running two commands. One is npm cache clean and run npm install. And the run npm install is what is going to actually search for the package.json file. So it would look for the package.json file inside the container, and whatever is specified here, it would install all those dependencies, correct? And the next thing that I'm doing is, besides the package.json file, I'm copying all the other contents in my directory inside my container, like my code. So we have a separate project code, right? With package.json, only your dependencies and packages will get copied to your container. Okay, and npm install would install those dependencies, but your actual Angular code, whatever code that you type for your application, those would also have to be copied. So for that reason, I'm giving a dot, meaning everything inside this directory would be copied to this particular path, the same path where my JSON file is and everything else is. So inside my container, the Angular application would be hosted, and I'm saying expose port number 4200, which means the Docker inside to my Docker container. Inside my Docker container, this Angular app would be hosted on port number 4200. Okay, guys. And inside the Docker compose file, I have said map this particular port number 4200 to the port number 4200 of my host machine. So that's why I can get to see what is there in my what services has been hosted. Okay. And the final command is that of starting npm. So npm start is what is going to make the actual application active, and this would create one container, and similarly it would go to the next Docker file and create the next container, and that's how the flow is. Let me also go to my next Docker file, my Express server Docker file, and show you what is there. Okay. So this Docker file is basically used to create my Express server container. Okay. And there's no much difference between this one and my Angular server container, except for the fact that I'm changing the port number where they are to be exposed. So inside my Docker, so my Docker would be looking for port number 3000. So this is the container, this is the port number it's running, and I can map this one to my 3000 of my local machine using the compose file, correct? You can either do it in the docker run command, but since I'm using a docker compose file, I have specified the port number mapping in the compose file itself. If you remember, I have specified the port numbers over here, right? Map the docker port to the host port over here. So that's how it is. And yeah, quite simply, that's how things work. And I've of course not created a docker file for my third container. The reason I told you was because I'm just using a base MongoDB image that satisfies my needs. So I can straight away go to my demonstration and start with executing my commands. All right. To execute your compose file, you should go to the directory where it's present. Okay, my compose file is present inside this folder of mine, main stack app. Okay, when I do an ls, you can see that I have my so this is the project which contains my Angular folder, my Express server folder, and my docker compose.yaml file. Now let's start the service by giving the command docker compose up. It's a very simple command, and this one command is enough to start all three containers. Now that's because it would simply execute the different Docker files and build the containers as per the need. Right, so let's just wait. My containers are up and running, and yeah, my server started at port number 3000. Okay. Okay, so it says my webpack is compiled successfully. Now I can go to my browser and open my port numbers. So this is my 4200 port, and when I try to access that, you can see that my Angular client is up and running. Right, so this is my Angular application, and this is a contactless application where I can enter details, and when I hit add, it would go into my database, and that database is my MongoDB database. Okay, now this is my MongoDB server, and this is also active, as you can see from the message over here. There's no problem here. And finally, this is my server port, and yes, foobar is a message that I have asked to print, and even my server is up and running. Now let me show you an example of how things work. If I just type in some data over here, now let's say I'm typing in the name test1. Okay, and here let me write test, and I'm going to enter the phone number as this, and if I hit add, then the data goes inside my database.